Today's learning target. Today's learning target. Yep. I can solve for areas of triangles using trigonometry, not using the standard formulas of 0.5 times base times height, 1/2 base times height. All right? We're going to use trig this time. So first, let's review a little something. If this is triangle ABC, what do the A, B, and C represent? Well, these capital ones represent the corners, the vertexes, or the angles. A, B, C. All right? So what represents the sides? Little a, little b, and little c, lowercase. Where would little a go? Yes. In between B and C, or you could say across from big A. Where would little b go? Across from big B. And little c would go across from angle C. All right? So just as a refresher, we should know that our angles, that's what this is, our angles are our capital letters, and our sides are our lowercase letters. So if we see word problems and they're uppercase and they're lowercase, you know which is which. And you know where they go. Little a, side A, goes across from angle A, which is capital A. You can also call side A, sometimes I'll do this. This is just side BC. It's the same thing. Okay, you can connect the two vertexes and put a line over it. That also means side BC or side little a. Nothing crazy. But here's where we're going to try and break a trig in. We just kind of went over that the area of a triangle is 1/2 base times height. All right, 1/2 base times height. So the question is, what does that have to do with trig? Well, there are 3 ways to write this formula. It's really just one formula, and I'll explain this in a second. Okay. The area of a triangle using trig can be 1/2 BC sine of A. All right? Now, because there are 3 angles, they write it 3 different times. It's really the same formula, and again, I'll explain it in a moment. It can also be 1/2 AC sine of B. Or lastly, it can be 1/2 AB sine of C. So as you look at those 3 formulas, what do you notice that's different between? Yeah, the angle is different. But the sides are also different. But what's one thing that's kind of similar between them? They all have 1/2, they all have sine, and what did you say? Yeah, they all have A, B, and C. Like this, for example, has A, B, C. So if I'm looking at my drawing here, I have A with side B and C. All right? This one has an A, B, C, but it has angle B with side A and side C. I'm starting to see a pattern here. And this one has A, B, C, but it is angle C with side A and side B. So if I'm looking at these, especially with the colors, what's one thing you notice that each one of these angles, how it gets used? What do you really need?
No, you need the angle sides.
Right, it's called the included angle. What that means is you need the 2 sides and the angle that those 2 sides form. That's called the included angle. So really, do you have to remember these 3 formulas? No. You just need to know that you need to have the 2 sides and the angle that it forms, and you can use this formula. All right? So now, where it says with trig, I want you to write this next, all right? We're going to go here. We're going to make our out to go away. Okay? So how can this be correct? Now, I'm not so concerned that you understand how this happens. I just want you to know that you should be able to apply the formula. If you have the 2 sides of the angle, you should be able to apply the area formula. But let me show you how this works. Okay? So, okay, if I say the area of my triangle is 1/2 the base, and now I need the altitude or the height. Okay, I'm not going to call it h because I don't want to confuse that with hypotenuse and trigonometry. We'll just call it C. Triangle 1. We'll call it F. We'll call it F. Okay? So you know the altitude forms two right angles here, so we got two right triangles. So how does this, the base times the height here is m in this case. How do we get this from it? Area equals 1/2. I guess it would be, we'll use the first one, base. So we don't have height. We're going to have C times the sine of A. Okay. How are these two equal? Let's figure this out. So what do we know? Well, how can we get rid of the sine of A here? Okay, here's angle A. Hey, look at here's the right triangle. How can we get rid of sine of A? What is sine equal to? Sine is what? Opposite over hypotenuse. So what is opposite of A? Yeah, M. And what is the hypotenuse of this right triangle? So really, opposite over hypotenuse is M over C, isn't it? So I can replace sine of A with M over C. And I'll still have 1/2 times B times C. Now let's take a look at what can I do with those last two terms? If I multiply them, what happens? The C's cancel. This is over 1, right? So what am I left with now? I'm left with 1/2 B M. That's how it works. That's exactly how it works. I mean, I won't have you prove that to me. I mean, but now that you see it, you should understand, oh yeah, I know sine's opposite by hypotenuse. If I put that fraction in here, I'm going to get a cancellation and end up with just the area formula, okay? So you should be able to apply this. So let's see how well you guys can do using the area formula. I'll give you guys a minute to do this problem. And when we do this problem, two things. You know you're going to be using sine, right? Which means I don't expect you to know what the sine of 120 is, or what the sine of 42 is, or 120 you should be able to find. But you're going to use a calculator. And when you use a calculator with sine and cosine, what should your calculator be in? Degree mode. Go ahead. So what did you guys come up with for answers?
78.
78. That sounds good. Thank you. Inches squared. Don't forget. You can write the word square inches. You can put SQ, period, IN. But make sure you label it. You will lose points if it's not labeled. Let's verify that. Let's verify that. We have triangle. A, B, C. I'm not drawing to scale. I'm just drawing a triangle and labeling the corners A, B, C. That's what it's. Angle A is 120. Visca, that doesn't look like what I know. I'm just drawing it to scale so we have some sort of visual. Right? Little b, this side, that's across from big B. And little c is 18. That's here, across from big T. Now, I don't need to say, okay, well, I gotta look at the formula, the one that uses the A, whatever. It's always the same. It's 1/2 times both your sides times the sine of your angle. And as long as your two sides make that angle, which means this is your included angle, you're good to go. So it is 1/2 times 18, which is 9, times 10, which would be 90, times the sine of 120, which is actually radical 3 over 2. So that would be 45 radical 3 if I wanted an exact answer. But you guys told me 78. I think it's 77.9 something, isn't it?
77.9.
and it rounds to 78. And let's just double check on the calculator because we can clear this out. And I have got 0.5 is the same thing as 1/2 times 18 times 10 times the sine of 120. Now I'm going to make sure I'm in degree mode, and I am. Enter 77.94, and it's just the nearest square inch. That will round up to 78. Perfect. Maybe, but they would give you another piece of information so you could find it. I mean, they would never leave you up to give you a question that you could not answer. Sometimes you have to use geometry like the next. After we do this one, the next seems like taking a step up, but it's not. All right, why don't you guys try the garden here? I'll give you a minute or two and see if you come up with it. All right. You guys are telling me 67?
67.
Yeah, 67. What would the label be? Square feet. Square feet. Square feet. All right. Landscape architect is designing a triangular garden to fit in the corner of a lot. So let's say this is where the lot you're going to build your house. Nice lot like this. Nice home you're going to have right here. Here you're going to have a dog and he's going to poop right here. And after years and years of picking up that poop, you're going to say, I wish I didn't get a dog. And then you're going to not pick it up one day, and then there's going to be poop everywhere. So they're going to come over and be embarrassed. That's what happens when you get a dog. You have to stay on top of that poop, picking up stuff. That's why you get a quality spring-loaded pooper's poop. You don't want to reach down the bag. Anyways, let's get off the dog poop and solve this. All right? The corner of the lot forms a 70-degree angle. Now, here's a corner. Let's call it 70 degrees. All right? And the sides of the garden that you're going to draw, put here, or build, 11 by 13. There's your triangle right there. They want the area of that triangle right there. Okay, so 1/2 times 11 times 13 times the sine of 70. Let's see if you guys were actually correct. 1/2 times 11 times 13 times the sine of 70. Oh my goodness, it's 0. You guys were wrong. Okay, so that is 70. 61.18. No, 61. 67.18 is indeed 67, and make sure your label is in feet square. Absolutely good. Goodness is good. You guys are getting this. And here's where the curveball happens.
That's easy, I'm done.
Here's where the curveball happens. You guys, what do you have? You know what you got?
I remember.
You sure that should be familiar? Algebra 2 and trig students have to do things like this. Now, let's look at this. We'll do this one together, the next one I'll let you guys do on your own. The sides of a parallelogram. Well, I know a parallelogram. The opposite sides are parallel and congruous. Okay? So they say one side is 10, and one is 18. I'll make that one 18, which is a little bigger. So if the top is 18, what's the bottom? The bottom is also 18. If the left side is 10, what's the right side? 10. Has to be. Okay? Now, one of these angles in the parallelogram measures 46 degrees. I don't know, this one looks like it might be 46. Doesn't matter as long as I label one. Question. Just a quick review of geometry. If the bottom left corner is 46 degrees, what is the top left? Top left. And what is the top right? The top right would be 46. Yeah, the top right would also be 46. So what would the top left? 134 because...
Oh, there's 100.
Yeah. There should be 360 degrees total in the four corners of a quadrilateral. But a parallelogram, consecutive angles should be 180 degrees. Okay? So... but I know areas of triangles, so what do? Yeah, I'm going to draw a diagonal that goes from here to here. Now I have this triangle here. The beautiful part is, when I find the area of triangle 1, triangle 2, is the same area. It's the same numbers. 10, 18, and 46. 10, 18, and 46. So there are really two ways to do this. And there are mistakes to be made. So make sure you are careful. If I want to find the area of triangle 1, it is 1/2 10 times 18 times the sine of 46. Can someone tell me what that is and give me 2 decimal places? 64.74. Anyone else? Well, let's make sure he's right. Is that what everybody else has? Okay. So if this area is 64.74, this also has to be 64.74. Which means if I just add those together, you get 129.48. And they went to the nearest square centimeter, so what would that be? 129 centimeters squared. Now be careful. Don't round until you get your final answer. Like, what if I rounded this to the nearest centimeter? What would that be? 65. And that means I would double that, and my answer will be 130. That'd be wrong. So don't round until you get your final answer. So that's the first way to do this. The second way is like, instead of getting my 64 and doubling it, I'll just double this right here. So I'll write it as, well, I have 1/2 of 10 times 18 times the sine of 46. I'm just going to double this whole thing, right? Well, what happens when I multiply the 2 times 1/2? They cancel out. So in my calculator, I really just have to put this, and I get 129.4, etc., which is still 129 centimeters squared. But it is easier, but be careful here, because you know what people do? They double this. They're like, oh, it's a parallelogram, I got to double it. And they forget, oh, I already did. So people would give me, you know, what would that be? That would go to 258.8, and they give me 259. So be careful. Use common sense. If you do this method, I don't think you'll ever go wrong. But if you know that the 2 and the 1/2 cancel, just make sure you don't double it a second time. All right? All right? So, why don't you guys try this problem right here? Ooh, I love those radicals. Okay, so you guys had some time to do this, and 1, 2, 3, or 4?
4.
I'm hearing 4 from a majority of you, so let's figure out if you're right. We have a parallelogram I like to draw. And there's a parallelogram, and sides are 4 and 5, which means this is 5, this is 4, and one of the included angles between 4 and 5 is 60. So this is great. So I'm going to split this in half, but what I'm going to do, instead of finding out the area of the one triangle is, and then doubling that, I will just double the formula itself. So it is 2 times the area of my triangle, which is 1/2 times 4 times 5 times the sine of 60. Okay, these cancel. So 20. 17.1. Let's do this. 60. And oh, it's 0.32050. No, I'm kidding. Okay, so this is what it is. So how do I know that that's choice 4? Thank you. If I put 10 radical 3 in a calculator, which is choice 4, it's identical. That's how you know it's choice 4. It's exactly what choice 4 is. No, well, I'm going to show you how to do it. So here's what the answer was, and here's what option 4 is. They're identical, therefore, that's the answer. Now, if this was not multiple choice, and they said they want their answer in exact form, that means no irrational numbers. These are irrational, they go on forever. You're going to have to represent it as a fraction or have a radical in it. Let me show you. Let me show you something. All right? We're going to do it this way. We're still going to have our formula. it is still 2 times 1/2 times 4 times 5 times the sine of 60. These still cancel. This still ends up being 20. But what is the sine of 60? How can I get the sine of 60 so it's not an irrational number? Any suggestions? Any thoughts? How do I get this so that it's not an irrational number? You can't do math under a calculator, it's irrational. So if it's not a fraction by itself, it's got to be a fraction with a radical in it. Look at our answers, they have radicals. So how do I have sine of 60 with radicals? No. Here we go, you ready? What if I drew an altitude here? That becomes a right triangle that also has a 60-degree angle. So if I draw a right triangle, and let's say I have a 60-degree angle in it, this has to be 30. And what are the sides of a 60, 30, 90 triangle?
3.
It's 1, 2 for the hypotenuse, radical 3. 1, 1, and radical 2 would be for 45, 45, 90.
Sine is opposite.
Sine is opposites over hypotenuse, absolutely. So what's the sine of 60?
Radical 3 over 2.
Beautiful. So this turns into radical 3 over 2. Well, that's still not 10 radical 3. What do I need to do to make it so? I simplify by 2 goes into 20. Don't cross multiply, stop. Reduce. Reduce. If I were to multiply these two together without reducing, I would get 20 radical 3 over 2. And 2 goes into 20 10 times. There's your 10 radical 3, which is what you would have to give me if I wanted an exact answer. Okay? Good. Good.